to you. Happy birthday, dear Nelson. Happy birthday to you. Yay, Nelson, happy birthday. Okay, moving on. It's time to learn integrals that involve inverse trig functions. Now, if you'll notice, there's only 3 formulas on the board: arcsine, arctan, and arcsecant. You actually memorized all of these, all 6 formulas going forward first semester.
Oh yeah.
You've probably just forgotten since then. But if you recall, the derivative of arcsine and arccosine are identical. The only difference between the two is that the derivative of arccosine is negative. Same thing for tangent and cotangent, same thing for secant and cosecant. Because the derivatives are identical and only off by a negative, when we do the antiderivatives, they're the same. So we don't do arccosine, we just do negative arcsine if it's negative. Okay, so traditionally you just do those 3 functions. You could do the other 3, but nobody does. They'll look at you funny, right? So anyway, so you've got those 3. So you have 3 inverse trig antiderivatives to memorize. Notice these aren't the antiderivatives of arcsine. It's antiderivatives of functions where the answer is arcsine, arctan, and arcsecant. Okay, so we're going to do a couple problems first just to kind of get your feet wet so that you get familiar with the formulas and how to plug into them. Let's do a 5. Now, there are subtle differences between each formula. So, if you look carefully, 2 of these have roots in the denominators, right? So, sine and secant both have roots. Hey, and they both start with S. Tangent doesn't. So, you're looking for, if you have a root, it's going to be a sine or a secant. How do you know which one? Well, if there's an x in front, it's a secant. Okay? All right, no root, it's probably an arctan. For the answers, sine is the only one that doesn't have a 1 over a in front. Now, I brought up in first period, and everyone looked at me funny, but I'm pretty sure I'm right, that sin in Spanish means without?
Yeah.
Yeah, okay. So if you think, like, sin, it's without the 1 over a, right?
Hey, yeah,
there you go.
Yeah.
Okay, so, so there you go. So anyway, so the other 2 have the 1 over a. They all have an x over a, and the only other difference is that secant, you put an absolute value around that x. Okay. So for this first example, would this be a sine, a tangent, or a secant?
Secant.
It's a secant. Now, how do you know it's a secant?
That's essential.
Because there's a root on the bottom and there's an x in front of it, right? Okay. All right. And then it's just a matter of writing the formula for this one. The 5, does the 5 have a major effect on it? No, it's just a coefficient. So the 5 can just be multiplied by whatever your answer is. There's a 1 over a in front. How do we calculate that a?
It's a third.
Well, it's x squared minus a squared. So if a squared is 9, what's a? A is 3. So what we get for our answer is 5 times 1/3 arc secant absolute x over 3 plus c. And it's a matter of just plugging into the formulas. Okay. We'll try one more baby step problem before we move into the teenager type problems. So, here we have 1 over 4 plus the quantity x minus 3 squared. And the first thing we have to decide is which function would this be? How do you know it's a tangent?
No square root.
No square root?
There's no square root, right? Does this problem require a U-substitution?
Yeah. No, because that'd be pointless.
Correct.
Minus 3.
Okay, when your argument is just x plus number, you don't have to do a U-sub. You can, but it's not necessary. So you can do this answer without a U-sub. So is there a 1 over a in front of arctan? Yes, what's a?
2.
A would be 2 for this problem. So you get 1/2 arc, start to right side, arctan, and then what would go on top here? X minus 3 over 2 plus c.
Cool. Magic.
Are you gonna like give us trig problems, or can we just like look at the antiderivative thing and be like, oh, it has an x, so it's a secant one, or are you gonna like, I don't know, like change it up?
There's only one of these on your test, and it's a pretty straightforward one.
Oh, cool.
Okay.
So,
Code C.
yeah, there's only one on your test.
That's what we're learning about it today.
We'll talk, I'm going to tell you after we're done with the lesson today, I'll tell you about what's coming up, right, and when, so that you know where we are on the calendar and what's going to happen. Okay, so it's time to take it up a little notch.
Doesn't little D mean like a giant notch? Or just
No, a little notch.
Oh, wow.
There are two ways to approach this problem. And I'm going to show you both of them. The first way to approach this problem would be to do a U-substitution. Because we need, first of all, which trig function is this going to be? It's going to be a sine. So we need number minus x squared. We have number minus 16x squared. So the 16 is a problem. When you have a coefficient, you got to do a U-sub. But here's the trick. What do we let u be? You always let u be the square root of the term that's being squared. So don't let u be 16x squared. Let u be 4x. All right, so if u is 4x, then what's du? 4 dx. So I'm going to divide out. I get 1/4 du equals my dx. And I'm going to rewrite the function. So now, this 1/4, that's just a coefficient out front. So I get 1 over the square root of 7 minus u squared. That's why we take the square root when we do our u, is so that when we plug the u's back in, we get something squared minus something squared. Okay? All right. So now we've got something that we can easily convert to an arc sine. Is there a 1 over a in front of arc sine? No. No. But we do have that 1/4, so we got to multiply the 4th because it's a coefficient. All right, so we have u over a. What's a? Root 7 plus c, and then plugging the u back in. You get 1/4 arc sine 4x over root 7 plus c. Now, there will be problems that will pop up where you actually absolutely have to do the U-sub in order to do the problem. So there will be problems that will pop up where this is the method that you will have to use to do it. But for this particular problem, there's another way that we could have approached it. So I'm going to rewrite this problem. So this problem using an alternate method. So method 2. So if you didn't like method 1, you can do this. If it's just a simple coefficient that's the problem, you can factor it out. So I'm going to factor a root 16 out of my root. That means I have to divide everything in the root by 16. So I get 7/16 minus x squared. All right. Now, it's just a simple arc sine. Root 16 is just 4, right? So I have 1/4 times arc sine. And then this would just be x over the square root of 7/16. Oh, oops, I wrote my integral symbol, sorry. I don't know what I was thinking. Oh, it's gone. Okay, plus c. This and this are actually equivalent. Because if you rewrite this as root 7 over 4 and then you do your keep change flip, the 4 will go to the top. So this is a faster way to do the problem if you want to do it and can do it correctly. But there will be a problem or two that you might encounter in the next couple days that will require this method. Especially if you've got x's on top where you have to get rid of them with the U-sub. Yes?
If it's just a coefficient, can you not just say that 4x is your a and just plug in 4x into the equation?
But the problem is if you had that, you wouldn't have the correct coefficient, the 1/4 in the beginning.
Okay.
If you just put a 4x over root 7, you'd be off by that 1/4.
Okay.
That's why whenever there's a coefficient, you have to do a U-sub. Because you always got to divide out that coefficient. All right. You ready to take it up another notch? Are you ready now? Get ready because we're about to go up another notch. Okay. This next problem is fun because not only does it use what we're learning today, but it takes into account prior knowledge. And that's always good when you feel like you can put something you've learned in years past to use. All right, so for this problem, first of all, the fact that the dx is on top is totally irrelevant. You can put the dx over here and put a 1 on top. Just know that if you see a dx on top, don't let that freak you out, okay? It's just placement. This should freak you out a little bit, though.
Just
A little bit. Okay. What does this look like it should be? Which function? Looks like an arctan, right? And it is an arctan. So just that knowledge a lot of the times will be enough to get you to the right answer. Because these are usually multiple choice. And usually they'll do a sine, a secant, and a tangent, and then maybe 2 other random weird antiderivative values, and you can just pick the tangent and be done. Yay, right? But say they're all arctan, 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 and they're going to make you figure out what the answer is. So now you're stuck doing it. Okay, so here's the thing. Arctangent is 1 over number squared plus variable squared, or variable expression squared. So we need to get this somehow as a variable expression squared plus a number squared. So here's what I'm going to do. I'm going to rewrite my denominator with a really, really long fraction bar, because that is always a nice help. Adding space, oh, I'm going to mute this, it's going to blink on in the next one. Mute, blink. Adding space always helps, right?
Yeah.
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 Okay, it's always good to have some space, right? We all need our space. All right, here's what I'm going to do, and let's see if this rings a bell.
Wow.
I'm going to take the coefficient of the x term, and I'm going to divide it by 2.
CTS.
And then I'm going to square it, and I'm going to add it. But I can't just run around adding 9s to problems, right?
Yeah, you can.
So if I add a 9, I also have to subtract a 9 so that I am equivalent to the original problem.
Okay.
Okay? Do you all agree that that was a legal thing to do?
Yes.
Yeah? Sure.
All right, good. What did that accomplish?
Absolutely
Completed the
nothing.
square.
I completed the square.
Oh my god.
Ah. Now,
I know I did.
when you complete the square, and the process of completing the square is just taking the middle term, having it, and squaring it. That's all. All right? And that just gives you the constant that you need. What completing the square does is it gives you the constant you need so that this trinomial becomes what's called a perfect square trinomial. And we can rewrite x squared minus 6x plus 9 as
that.
x minus 3 quantity squared.
Cool.
How come it was always like so daunting and like no?
That's it.
That-
I don't know.
That's all there is to
It's
it.
called in
That is
some
completing the square. Now, what you're thinking of is solving a quadratic equation by completing the square, and then there's a whole bunch of steps beyond this, right?
Whoa.
But yeah. Yes?
How did you get from that to x minus?
Well, I haven't finished writing yet.
Okay.
But just so you know, the quantity here, the number that goes in here, is always half the middle term. All right, so just a little shortcut. So it's always x and half the middle term. Then, of course, you still got these two numbers out here, and so you just combine them.
Well, that's nice.
All right, I want everyone to take a second and see if you can go from here to the answer.
Yep. It's a 2. It's 2. Yeah. A squared plus x squared is 1 x squared plus a squared. Well, that's a pain. Put Fox on Thunder. Put Fox on Thunder. Let's see.
Is there a 1 over a in front of arctan?
Yeah.
What's a?
2.
2. So you get 1/2 arctan x minus 3 over 2 plus c. All right, that's not so bad, right? Let's take it up another notch.
Another notch.
Another notch. There are so many notches. It's great.
What's next? You gonna put us on ludicrous speed?
Okay, here we go. Oh, whoops, sorry. Oh, I just gave the problem away. That's a good thing I wasn't filming over here yet. Hopefully it's not on camera. There we go. There we go.
Oh, man, you really lose, don't you?
Okay. So here's what we have now. We have, this poor film. This one. So we have the integral of 2x minus 5 over x squared plus 2x plus 2. This problem's going to probably involve two things. What two things do you think this problem's going to involve?
Complete the square and U-Substitution.
That's right! Completing the square and U-Substitution. Now, which one do you do first? Well, when you've got a completing the square U-Sub combo problem, you need to do the U-Sub first. Now, just a little FYI. When you have a denominator where the degree is only 1 greater than the numerator, it's not even necessarily an inverse trig. It could just be a natural log. Because what happens is, when I take the derivative of this, I get the x, and then I end up with a 1 over u du kind of a thing.
Oh my god.
Right. So a lot of times, if you have a degree that's 1 greater on the bottom than the top, it's just a natural log integral. sometimes, so when you have number over x squared, that's an inverse trig. When you have an x over x squared, it's a u sub with a possible natural log. So let's do a u sub and see what happens. So our u is going to be the bottom, x squared plus 2x plus 2. And what's our du?
2x plus 2.
2x plus 2
Yeah.
dx. All right. Well, I don't have 2x plus 2, but I want 2x plus 2, right? So I'm going to make this problem become a 2x plus 2. But in order to not change the problem, I have to do a separate problem to make the total equivalent to the original function. So let's see here. I started with 2x minus 5. 2x minus 5 is the same thing as 2x plus 2 plus some constant. What would I have to add to 2x plus 2 to get 2x minus 5?
-7.
I'd have to add -7.
Hold it.
Okay. Now the good news about this is that this problem is the u sub one. We've already done the u sub. So we just replace. So this is equivalent to 1 over u du.
Cool.
This one is an inverse trig, but it requires what? Got to complete the square. Everyone take a second and complete the square on this guy. Back up. All right, what's half of 2?
1.
What's 1 squared?
1.
So I'm going to add 1, but then I also have to
Subtract 1.
subtract 1. What's the antiderivative of 1 over u? ln u. With an absolute value.
Yeah.
This one is equivalent to -7 over, what's the quantity that's being squared here? X plus 1 squared plus 1. Hey, we just go to our final answer now. So here's what we have. We have natural log of the absolute value of x squared plus 2x plus 2 minus 7 times, this is an arctan, but what's a?
1.
It's just 1, right? So this is just arctan of the quantity x plus 1 plus c.
Cool.
Isn't that fun? All right. I'm going to show you 2 more problems side by side that are straight out of your homework. So I'm going to give you like 2 homework gifts right now. And then once I give you these kind of little starting points, then we're going to stop there and talk about administrative stuff. Oh yeah, we're doing great. Doing great. There are 2 problems in your homework that I find interesting. Okay, so the 2 problems are 35 and 37. (35) is the integral of 1 over the square root of -x squared minus 4x. And 37 is the integral of x plus 2 over the square root of negative x squared minus 4x. These are very similar problems. There. Camera issues. There, that works. Okay. Okay, these are very similar problems. The first one looks like what type of a problem?
Sine.
This is an arc sine. The second one also could be an arc sine, but what would you have to start doing first?
U-sub.
You'd have to do a U-sub. When there's an x on top, it's a U-sub problem. All right? 37 is actually the easier of the two problems. 35 is a completing the square arc sine problem. In order to complete the square, you may or may not remember this, but one of the first things you had to do when you completed the square was you couldn't have a coefficient in front of your x squared term, so you have to factor it out. So when you complete the square, and half of 4 is 2, and 2 squared is 4, so we go plus 4. Normally what we do out here is go minus 4. We're not. We're going to go plus 4 again.
Oh, yeah, 'cause
Why?
there's a negative.
Right, because everything that's in the parentheses is already getting multiplied by a negative. So what we actually did technically is we subtracted 4 from our original problem, so we have to add 4 to balance it.
Could you just move negative in before you do? No, you can't, okay.
Now if we were to rewrite this, you'd have 1 over, I'm going to put the 4 in front, it's 4 minus x plus 2 quantity squared, and now it's a very normal problem. So if there's no x on top and you got a squared term, it's an inverse trig, might be a completing the square. Here we have an x on top, you got to start with a u-sub. Your u is negative x squared minus 4x. Your du is negative 2x plus u minus 4. Is there something we could do with the du?
Factor out a negative
We factor out a negative 2, and what's left?
2. X plus 2.
So that means we could just divide the negative 2 out, and we have our exact problem. Be careful. This is not a natural log antiderivative, because this would not be 1 over u. This would be 1 over u to the 1/2, or u to the negative 1/2, and it would be a power rule problem.
Schmancy.
Okay. All right, good. So tonight's homework is in